Hello, I am Disha and I'm going to present today about my research question. Can we predict school dropout rates based on wealth related socio-economic indicators? So, why should anyone care about this topic? First of all, I used to work in a charity where we served unprivileged kids by teaching them. I've seen them, they don't have that much of opportunity, they don't get that much of proper education, so that's why they opt for the dropout. So this is our global concern. We should address these type of issues that actually affecting those vulnerable group of people, basically the poor, why they are actually opting from dropout. So from that point of view, this idea came to me to predict the drives that are actually affecting this type of groups, and by predicting those um, type of problems we can address how to solve these issues. First of all, this is a global issue. If the dropout rates in children are increasing, the economic growth of a country is decreasing. So that is my point of view. And by this scenario, first of all we should know like the interaction to the dataset, from where I got the data. The source of my dataset is the UNICEF out of schools primary division dataset. Primary division is basically those children who are actually having their education in primary levels. And the key variables I have chosen, like the features, are wealth quintiles, like from the poorest section of the society to the richest section, and the rural and the urban population percentage. And what is our target? The target is the rate at which students leave school, basically the dropout rates. And how I have pre-processed the data. So there were many missing values in my dataset, and I had to actually fill them in. And after that, I have also removed some outliers. Obviously, the main goal is to get the proper data and the accurate data so that we can also predict the accurate result. And I have also normalized numeric features to ensure compatibility with my techniques like models. Then the type of machine learning techniques used. So I have actually used supervised learning by splitting the data into 80-20 rule, like the training data set and the testing data sets. Training 80% and the testing 20%. And I have also chosen different regression models to test, like in different scenarios, how they are performing on these features. Like the regression models I have used is linear, lasso, and ridge. And why I have chosen regression? So typically classification models are doing classifying into different categories, but here we have continuous values. Like in this case, the dropout rates based on the other related factors like wealth levels and rural populations we are predicting. So that's why we need something in continuous nature. So we all know that regression models performs best in this scenario. Then the description of machine learning models I have used. So first of all, linear regression. Linear regression is the base type model of regression, which actually identify the relationship between predictors like the features and into the targets like the dropout rates. And why I have chosen linear regression? Because it's simple, interpretable, and gives us a clear idea of which factors are more influential. And then ridge regression. This is the model that actually prevent overfitting. Why? Why I have chosen ridge regression? It makes the model more reliable when there is overlap or relationship between features. Like we have different wealth quintiles, but they have a relationship from the poorest to the richest section. They falls under the same group. So this type of scenarios, ridge regression performs the best. Then comes lasso regression. What does lasso regression do? Perform feature selection by shrinking less significant coefficient to zero. So why I have chosen lasso regression? It helps focus only the selected important features. That's why. Then we will see the overview of data analysis and results. So here there's a graph we can see. It's basically the feature importance of our linear regression. So here you can see, like in the rural population is actually affecting the most positive impact on dropout rates, then follows by fourth quintile and poorest quintile. They also have a positive impact in uh, dropout rates. And second quintile section is also playing a negative impact here. You can see they're not actually affecting the dropout rates, and even in fact they are behaving oppositely. So these are the feature importance we are taking from our linear regression model. So you can see the results by this graph. Now comes the comparative analysis of different models I have used. So here the bar chart in the graph is showing the mean squared error, and the line chart is actually representing the R square, the coefficient of determination. So what is mean squared error? Mean squared error is basically the error in our model, and R square is basically defining the model performance. So here linear regression is our best performing model with the MSE. The error is 4.34, and where the performance is 0.903 is basically 90%. Accurate results it is giving. Then ridge regression is MSE is 9.14, like the error is that, and the lower R squared is 0.893, like the performance is 89%. Same goes with LISO, is MSE is 8.98 and the performance is 89%. So in this scenario we can see why it's important. It demonstrates that linear regression is the most accurate model, and ridge and lasso regression also has the robustness in our model. So every model has their own importance. So the remarks is here what I learned. Like socio-economic factors like rural population and wealth levels significantly influence school dropout rates. Machine learning models, especially linear regression, can effectively identify these relationships. And what is the practical implications? Results can guide policymakers to focus on rural education and address wealth disparities so that we can reduce dropout rates in children and they can get proper education. So here are some limitations. First limitations is model assumptions. Linear models may oversimplify complex socio-economic relationships. So the thing is how linear regression is performing is taking the linear relationship. Then data quality, missing data imputation and lack of variables like school infrastructure may introduce biases. Robustness, ridge and lasso reduce overfitting, but they still rely on linear assumptions. Generalization, dataset biases like geographical and temporal may limit applicability to other regions and scenarios. Obviously, you have to see other regions how they are actually having the data. So by this, thank you. I hope you have enjoyed my presentation. Thank you so much.